Hello, ladies and gentlemen. Welcome back to my channel. My name is Mr. Arias, and this is Math to the Point. In today's class, we're going to find out how you can come up with any recursive formula for any given arithmetic sequence that you're working with. Now, that being said, I'm going to put some notation on the screen. Feel free to copy this down, and then we can explain what this means with an actual example of a sequence. So basically, the recursive formula of any arithmetic sequence goes like this. We have this term, which is on the left-hand side of this equation, and we're going to call that a sub n. So this is a term that I'm going to call a sub n. And what this means is that this is the value of any given term that's placed in the sequence that you're working with. It could be the 20th term, the 40th term, the 71st term. It's technically the value of that given term in your sequence. So this is any term in your sequence. Okay? And when I say the term, I actually mean the actual value of that given term in your sequence. And the second piece of information that we notice here is this a sub n, and then we have this -1 that's subtracting the n. This term is nothing but the term that appears before the n term, which is a sub n. So if we're talking about that 20th term, then for a sub n, that means that a sub n -1 would be the 19th term. If we're talking about a sub n as the 5th term, that means that a sub n -1 would be the 4th term, which is always the one before. So this is the previous term. Okay. And then lastly, the last piece of information that we need to review here is the value of d, which if you have watched my videos over the past few days, you would notice that when we're talking about arithmetic sequences, d is the common difference that separates the terms in your arithmetic sequence. So this one is our common difference. And this is the main proof that you have an arithmetic sequence in the first place, if this value exists. Common difference. Okay, so this is the notation that we need right now. Feel free to copy it down, and then now let's apply this information with an actual example. So we have an example here, which is the following. This is an arithmetic sequence, and we can prove it by just investigating the terms and by analyzing the fact that if you notice, each term is being separated by the same amount, which in this case is +3. Okay? Now, also, I want to make a comment on this sequence. I said that the n term, the a sub n term, actually, is any given term in your sequence. Now, I also want to mention that this n right here is helping me visualize which kind of term I'm talking about right here in this problem. For example, in mathematics, we usually call the first term a sub 1 by following this notation. I'll just quickly fix it really quick. Right here. So this is a sub 1. So notice that a sub n became a sub 1 because n is technically denoting the term's position on the sequence. And that being said, we can call 5 a sub 2, which is the second term. By the same reasoning, we have 8 as a sub 3. 11 is a sub 4. 14 is a sub 5. And then if you can just kind of like keep going like this, you will realize that any given term of your choice in this sequence can be called a sub n. And it's going to just take the value of the position of the term in your sequence. Okay, that's it. So again, all we need here to come up with the recursive formula is to find just the value of the common difference. And then a sub n and a sub n -1 are going to just stay the same in that given final formula. So that being said, because we just found out that the common difference in this sequence is +3, that is the value of d. So this value that repeats across my sequence is the common difference, also known as d, the d variable in these problems. Common difference. Okay, so the final answer is like this. So like I said, a sub n is not going to change, and a sub n minus 1 is not going to change either. The only thing that we have to take into consideration here would be the common difference, which is positive 3. And this, ladies and gentlemen, is the recursive formula. So what this means in mathematics is that if you're trying to find the n term, it could be the 20th term, the 40th term, the 50th term, any term in your sequence, all you need to do is you need to take the previous term, which is a sub n minus 1, and then add the common difference, which is technically how the sequence is being built in the first place. I need the previous term within my sequence so I can add the common difference to it or subtract it. And then that will give me the next term in that sequence of terms. That's it. So we just need the value of d, basically. Let's do another example. So in the second example, we have the following sequence. So if we investigate it and we look into this sequence, what we would notice is that this is a sequence that is being separated by positive 2. So I'm basically adding 2 to each term so I can get the next one. Okay, so if I add negative 5 plus 2, I'm going to get negative 3. In the same way, if I add negative 3 plus 2, we get down to negative 1. And then by adding another 2, you get up to positive 1. And then lastly, if we add 1 plus 2, we get 3. So this shows that this sequence is an arithmetic sequence, and it shows that the common difference is positive 2. So this is the value of d in my sequence. This is my common difference. Okay, so that being said, all we need here is just to place this value of d into my formula. So again, we have a sub n is equal to a sub n minus 1, the previous term, plus the common difference, which is, in this case, positive 2. Okay, now let's do an example on what this to show what this actually means when we're talking about the formula. So for example, if I'm trying to get the next term right here, which in this case would be a sub 5, notice that the value of n turns into a 5 because I'm talking about the next term, which is the 5th. Actually, it's supposed to be the 6th one, right? Let's do a quick fix. This is supposed to be the 6th term. What am I thinking? There you go. So if I'm supposed to get the 6th term, notice that now the value of n changes to 6. So if I place that value for my n, then we get the following equation. A sub 6 is equal to a sub n minus 1 because we're talking about the 6th term. The value of n becomes 6, and now we're subtracting 6 minus 1. Okay, so if I subtract 6 minus 1, we get now a sub 6 is equal to a sub 5 plus 2. And what this means is if I want to get the value of the 6th term in my sequence, I have to take the 5th term, which is the previous one, in this case, positive 3, and then I would have to add the common difference, which is positive 2. And that's exactly how we get the next term. If I want to get this term, I have to take 3, which is the previous term in my sequence, and then if I add the common difference to it, we get the next term, which is the 6th one in this case. So then here we add 3 plus 2, and the answer will be 5. So that means that 5 would be my 6th term, also known as a sub 6. So this is kind of an application of this recursive formula of an arithmetic sequence. Thank you for watching the video. I'll talk to you next time. Have a wonderful day, ladies and gentlemen.